can do it when we use it. Hello, everybody. Welcome to day 2 of the FCMaP Summit. For those of you that weren't here yesterday, I'm Christy Erickson. I'm the FCMaP coordinator. Yesterday I thought was fantastic, especially we were really excited about how much online participation we had, and the transition for the remote to in-person seemed to be great. So hopefully everything goes as well today. And we were really happy with the turnout. I think you said yesterday we had 80 in-person registered and almost 45. It was just under 45, I think, online. So we were excited about that. I'm more excited if this clicker works. Everybody see? I was going to say everybody see. And so we're very excited that all of you actually took the time to be here. We know how busy everyone is. So thank you very much for your participation. And of course, we want to thank our sponsors because we rely heavily on this as we don't have a budget. So we really appreciate the contributions that you've made for this. So thank you very, very much. So just some of the logistics, which I think everybody should be familiar with, but for online participants, you are able to unmute yourself. But if you raise your hand or put something in the chat, you're welcome, and please do join us in the conversation and discussion at the appropriate times. Don't have your camera on unless you're presenting. And Kat Dietrich will be monitoring the chat, so there is someone there that will be paying attention. In person, for those of you that weren't here, the bathroom is just down the hall to the right. All of the food lunch today will be in the common area right out here. And there's a fill station by the bathroom for your water bottles. Cheryl wants to make sure you know. And I don't blame her, it's a good thing. So with the agenda, just a quick overview. Today we will have the FSMI update and contractor updates. So I'm sure we're all excited about that. We will then go over the interim gap analysis that we have from FCMaP. And then we'll get into our lightning talks, which will be the presentations and then a panel discussion before wrapping up.
Thank you for the opportunity to present here today.
Sorry, it's going to go right into it.
With DEP's Office of Resilience and Coastal Protection. I'm excited to provide an update on the Florida Seafloor Mapping Initiative.
I'll go back. I think I could go back. I didn't think it was going to start because okay, so I would very quickly, Alex Reed is, she sent a recording for the FSMI update. So this is going to be a little different. We've been struggling with this a little for 2 days. So once we get the volume right, I will make sure that it's turned. We'll start from the beginning so everybody can hear it.
Thank you for the opportunity to present here today. I'm Alex Reed with DEP's Office of Resilience and Coastal Protection. I'm excited to provide an update on the Florida Seafloor Mapping Initiative, or FSMI for short. I do wish that I could be there with you in person, especially for the Q&A session, because I always gain such great perspective and insight from that interaction. So if you do have any questions, my contact information will be on the last slide, and I do hope that you will reach out. Most of you are aware of the FSMI project.
I'm going to start it over so that we can hear everything. We don't want to miss anything.
Most of you are aware of the FSMI project, so I do apologize for this duplication, but for anyone new to the concept, let me go over a few highlights to recap. FSMI was first contemplated during the 2021 legislative session, and it was funded with $100 million starting in fiscal year 21-22. The unique thing about the funding is that it is federal American Rescue Plan Act funding, so there are additional stipulations required with its use. There are reporting requirements needed, and there's a very definitive expiration date. All funds must be encumbered by December of 2024 and fully expended by December of 2026. For this effort, DEP developed a two-part solicitation process. Part 1 identified the qualified vendors for each data collection type, topography LiDAR and multi-beam sonar in 3 different depths, 0 to 20 meters, 20 to 100 meters, and 100 to 200 meter depths. The solicitation contemplated awarding contracts to up to 5 different vendors for each data collection type within each of the 6 regions identified for the project. Ultimately, contracts were awarded to a total of 9 vendors statewide for both LiDAR and sonar data collection. With these qualified vendors under contract, Phase 2 is a simpler process and allows for the task assignment for specific project areas. These task assignments are awarded on a low-cost basis. Simultaneously with this solicitation effort, DEP was working with a contractor to develop a quality management plan that identified consistent data collection protocols for each vendor to follow. It also outlined the requirements of professional oversight needed to meet state law. Professional survey services were then envisioned to be retained for each data collection vendor under a separate contract. Most of the standards for the data collection methodology and quality level have come from federal standards. We did want to benefit from earlier efforts by FCMaP to prioritize data collection needs. So we started with the 2019 priority map and then surveyed state agency partners and other stakeholders to ensure that we accounted for any needs identified since 2019. We also wanted to ensure that we were maximizing the use of existing or anticipated data sets from our federal partners. We completed a review of existing data sets available through federal portals to see what met our quality level. We also wanted to make sure that any existing data that we reused or upcycled was not located in an area that had been impacted by a recent storm or emergency event. If so, we would identify these areas for recollect. We are very excited to partner with USGS CONED, who will be helping us to stitch together data sets from this effort, existing bathymetric data sets, and then also the terrestrial LiDAR data set recently available. For transparency and awareness, the state wanted to create a data sharing portal. So thanks to the State Geographic Information Office, who assisted us with this effort. And I'll show you a little bit about that in a minute, but it is designed to be a one-stop shop for data and information on FSMI. From the FGIO webpage, you can click on the Initiatives tab and find the FSMI webpage. There's a lot of great information on the history of the initiative, solicitation documents, contract information, and then as you scroll to the bottom, you'll find a feature service dashboard. The dashboard map has 2 tabs, the project area tab and the collection progress tab. On the project area map, you'll be able to see the 6 regions around the state in both near, shore, and deeper waters, and this will be in dark green and light green respectively. You'll also see dark blue polygons, and these are areas of previous data collection that we have decided to retain or upcycle rather than recollect. If you hit the FAQ and link button in the top right, you'll be able to access web services, downloadable data, solicitation documents, and also the quality management plan, or the QMP. Once you hit the Collection Status tab, you'll be able to track the vendor data collection status. This information is provided in a feature service directly from each one of the vendors. So for this LiDAR collection, you'll be able to see exactly where we are through each phase, from planning to final acceptance of the data by the department. I would like to point out that there has been some data that's been fully accepted by DEP, but this feature service has not yet been fully updated, so you should see some polygons in Kelly Green in the very near future. We are in weekly meetings with each one of the vendors to gauge their progress in data collection, answer any questions, problem solve, and we are very happy with the quality level of the data that we are seeing coming from this effort. And we know that you'll be excited as well. We are glad to report that each of the vendors has been able to push the initial boundary of their contract past that 20-meter boundary. So we are going to be able to collect some data in some deeper waters, and we wanted to expand their contracts to be able to accept this data. So we're seeing great progress. So where do we go from here? The LiDAR data collection will be complete by December of 2024, with all data and digital elevation maps submitted to the department. In planning for the sonar collection, we are currently identifying LiDAR data gaps in existing data sets that have been chosen for upcycle. We're also working with our FSMI LiDAR vendors to anticipate any data gaps during this current collection effort. And we're reviewing existing sonar data sets for consideration of upcycling. As we identify any data gaps, we will then be able to move forward with the task assignment process for specific LiDAR collection areas. As a companion to this process, we are working with vendors to complete a sonar QMP, or quality management plan, that we hope to circulate to our sonar vendors in the next week or two. This QMP will outline all of the requirements of the data itself, as well as some procedural processes and reporting requirements that will ensure that we have a quality product in the end. While we still have a long way to go, I am inspired with what we are seeing so far, and we are looking forward to creating a final product that we can all be proud of and that can be invaluable to resource practitioners statewide. I do want to take a moment and express some gratitude to our state leadership. Thank you for providing this funding to tackle such a monumental task. To FCMaP, thank you for raising awareness of this need and helping with the early prioritization efforts that got us off on the right track. To our federal partners, thank you for past, present, and future guidance and expertise. To the State Geographic Information Office, thank you for keeping us on track and finding creative ways to make this data accessible. To our vendors, it has been a pleasure to navigate this process with you, and thank you for all of your patience. And to the RCP team, thank you for all the blood, sweat, and tears. That goes out to our FSMI and our Resilient Florida teams. So thank you very much. If you have any questions, I hope that you will reach out, and we will make updates regularly available on the FSMI webpage. Thank you all.
All right. Good morning, everyone. Alex will not be taking questions at this moment, but I'm sure you can email her. I'm Renee Baumstark. I'm going to just briefly introduce our speakers, and then I will moderate our discussion after the break. So again, yeah, this is the FSMI's portion of the agenda where we're getting updates, and we're going to start off here with Malcolm Elliott from FUGRO. And Malcolm, hopefully the clicker will work for you. Point it that way.
All right. Well, thank you for having the vendors to come in and talk with you about what we've been doing for the past better part of a year. So as mentioned, my name is Malcolm Elliott. I'm the project manager for FUGRO USA Marine. I've been managing this project and all other RAMS projects in the United States. So does it work? It works. So I'm going to go over the two regions that have been awarded to FUGRO, the Northeast and the Southeast. I'm sure as you're familiar with, as Alex Reed's presentation just outlined the contracting. I'm going to talk a little bit about FUGRO RAMS and also the next steps for completing the 0 to 20 meters and beyond in Northeast and Southeast. And then some Q&A. I'll skip through this pretty quick, but FUGRO, as I mentioned, I represent the hydrographic team in Houston and in the Americas, rather. In particular, though, I'm part of the Coastal Resilience Group, and Cheryl will be mad at me for not updating this slide. It's a little bit different than this. It's not as simple, but airborne LiDAR is it's really projected by having contracts like this, like the FSMI coming forward and really making it so this technology can be used. Apologize, I'm trying to go forward and it's not letting me. There we go. All right, so A little bit of intro on what airborne Bathy LiDAR is. So it's a light detection and ranging technology. It shoots a green laser in the 495 to 570 nanometer wavelength into the water column. It then penetrates the water surface, or it should penetrate the water surface, hits targets in the water column or on land, and then reflects back to the scanner. There's all kinds of different Bathy LiDAR systems on the market. It's a very small market, and one of the things that Fugro does is we develop our own system, so Fugro RAMs. So for the Florida Coastal Mapping Program, we were awarded the Northeast and the Southeast blocks. Comes out to about around 100 square or 100 or 10,000 square kilometers from Jacksonville all the way down to Miami. So last June, we mobilized 2 different aircraft with the RAMS LiDAR scanners. The first 20% was due on December 15th. We brought that to the client. And then Fugro has also gone through and we've collected up to the 60%, which was due. The next 60% for our region was due this month. So we're doing the final delivery this week. And we've stood down just due to poor water quality since January and February. And so, as Alex mentioned in her previous discussion, we're then extending some of the deadlines out a little bit to hopefully allow us to collect in better conditions with better seasonality. So for us, with the different scanners we've used, we've collected about more than 80,000 kilometers online, over 3,500 lines, and over 200 missions. I think it's around 220 missions in total that we've completed since we started in June. When we did mobilize, we calibrated over the Universal Test Site in Fort Lauderdale. We did some multi-beam ground truthing before we actually went ahead and began the project. So we did some ground truthing over the collection site, and we dropped some targets from NAVO over the same area, just to make sure that we were actually seeing with the RAMS system what we should be, and to make sure that there were no offsets, no biases. At the same time, when we did that, we also did a multi-beam transect at the border of our region, and then also its technical term is zigzag all the way up the coast, just to use as a baseline. But this is a depreciated calibration grid. It's not quite the same, but what you can see, if you're not familiar with Bathy LiDAR, as you get closer into the coast, the underlaying on the right side, those are all multi-beam planned lines, and just to kind of respect how closely those are planned together and how inefficient that is compared to Bathy LiDAR to cover the same area in 8 swaths and 20 minutes, it's quite dramatic. So I have to talk a little bit about seasonality. So in the Northeast, and if you were at the mid-year summit, I would have gone over this as well. So we do satellite-based reconnaissance before we go on to any project. And we try and project based on the 490 nanometer band, or it's a product that the ESA and NASA both produce, is publicly available to everybody. And we try and project when is the best season, when is the best month that we can go and collect in each area. So we're trying to get to the 20-meter boundary. So on this graph here, the yellow line would be 20 meters. So we're looking at May, June, July, maybe August is the best months for seasonality in the Northeast. Similarly, looking at the Southeast, it's a bit better. In the Miami area, pretty much south of Fort Pierce, you're going to have good Bathy LiDAR collection all year round. But then once you get north of Fort Pierce, you start to dip a little bit. So we're looking at April, May, June, through almost until September. So that's based on just about 20 years of historic sensor data that we've accumulated from the different publicly available sources. But what does that look like in 2023 to 2024? So you probably noticed on some of the maps before, we split our project up into blocks. So because we have to deliver this in 20% increments, we cut each project into 20% chunks. So doing the math there, there's then 10 different collection blocks that we are delivering. So on the bottom, you can actually see the seasonality of each of the different collection blocks since we started last June. And the big one here in the top is the Miami, followed by, or the furthest south block, followed by the next furthest south block. And you can actually see you can't really see the graticule, but the 20-meter line pretty much ends in September. So that kind of goes along with what we had projected. Now, that doesn't mean that into October there's going to be good days for collection, or there's not going to be any good days for collection. There are still a handful, but it's by and large the best season is in the summer. So what does that look like when we actually plug in the data? So this is the farthest north block, so that little tiny one that you saw in the at the very top off of Jacksonville. So we collected this starting in June, and pretty much everything from Jacksonville south, it's going to be heavily dependent on outflow from the St. Johns River and the St. Mary's River. This is the first 20% that we had delivered to DEP. And I mean, the Northeast is probably one of the most challenging areas to collect in the state, full stop, just because of the outflow from the river. And the one thing to note here is the very fine line that you're seeing. That is the boundary of state waters. So we were not able to actually collect inside of state waters due to the PLS agreement not being signed. So I know Alex Reed had mentioned that in her previous presentation. So because we couldn't collect in any farther at that time, we were forced to collect that outside of the preferred window. So I'm hoping that we're going to be able to go back in this spring and maybe tidy that up a little bit, and particularly in the near shore along the beach. So what does that look like? So the overlay that you're seeing here is actually our projected, the best possible month over the last 20 years. So from 1997 to 2022, as I had mentioned earlier. So it's really rough, but the polygon shows the best coverage month, which is June, and it actually happens to line up with some of our acquisitions. So as I mentioned, we had planned some reflies to fly along the coastline, and we think that kind of along the beach we should be able to get more penetration, but it's going to be really difficult either way. And you can also see the state boundary as well, and how that lines up with our coverage in Block 5. Well, we call it Block 5, but it's the furthest block north. And we have to balance this. So what is a good day for collection in the aircraft? I don't know if you can see that, but there's kind of a line in the water column, and that is sediment outflow from the rivers that we're dealing with on a day-to-day basis. So if half of the line is good, we still have to go and continue production and hope that the other half is good tomorrow when we go in and collect it again. So it's very intermittent. It's a very active environment. And just to kind of further that point, even though these are some of the best months, these are images that were taken from the aircraft. We take these every day just to look at what the water quality is like. So if the first 2/3 of this line is good, we have to keep going and hope that when we go on the next adjacent line, that 2/3 of that line is also going to be good and is showing us coverage. And this is a shot just from the very first mission that we flew in June, and just showing that material transport, that is pulled down from the Jacksonville area and along the coastline. And so that maybe, the first mile or maybe kilometer and a half of bathy from the coastline out, it's really difficult. There's a lot of material in that water column. And just to kind of show what that looks like. So this is a lesson. I mean, we knew that this was going to be a problem when we went up there. So when you're down in the Miami area and further south, the Gulf Stream actually it clears out the water column and makes it a lot easier to do this work. But where we are here, we see a lot of outflow from those two rivers, and it just kind of gets swirled around down in the. I know it's another technical term. Better news, the Southeast it shows us really good coverage. So this was the very first 20% block that we delivered in the Southeast. We knew that it would be a lot easier to complete. There's really no voids apart from a few little areas that either are going to be touched up with reprocessing to try and get some more coverage out of the raw data files. But this was delivered in December, and some of the latest flights were flown in December. So that just goes to show that, again, in the Southeast, the seasonality is a lot better. We can kind of fly that almost any time of the year. And when we put together everything we have, this is kind of what our coverage looks like. You can see that the first couple blocks in the Northeast, right along the shoreline, that's the most difficult part to collect. So you can kind of see a few voids up there. But the area that we have left to collect, the 80 and 100%, is everything north and south of Cape Canaveral. So those immediate areas are what we have left to complete. The one thing that I'm not showing here is our effort in the deeper waters as well. I've got some eye candy. You can come in and chat with me after the presentation. But we've done some pretty extensive recon lines to really extend what our coverage can look like. So we're going we're contracted to the 20-meter ISO bath, but we're going to the 25, 30 in some places, in particular in the Northeast. So while in the Northeast, it's really difficult to get that coverage near shore, the farther we go away from that outflow, the more coverage we're going to be getting, which is great. All right, so what is FUGA-RAMS? I'll try and do this really quick. It's the Rapid Airborne Multi-Beam Mapping System. As I mentioned earlier, the green wavelength is what we operate in. It's a 532 nanometer, so it's visible to the human eye. If you're flying at night, you can actually see the pulse light up the water column, same as the other systems. It shoots out around 1,000 observations 60 times a second. But it shoots them out as one image and then pulls them back, splits that image into different waveforms. The one thing that's unique about RAMS is it's modular, so it can be deployed in different configurations. It's not limited to one particular install type. You can mount it with other bathy lidar systems, topo bathy lidar systems, other topo systems. You can mount it alone with cameras, whatever your project needs are, but it's actually designed to be able to go onto a drone. So that's kind of the next step. And you can see it kind of installed in an aircraft there. So all the systems are owned and operated by Fugro. The sensors have been in commercial development. Well, they've been in development for longer, but they've been in commercial use since 2018. It's based on 20 years of ocean mine detecting sensors, which then Fugro took that technology with our partner Arete and converted this for use in charting and mapping requirements. And so with our partner, we're continually evolving this program and making new sensors, or adapting new sensors to different applications, but not just the hardware, also the software. So Fugro owns everything, and I'm going to talk to that a little bit in a second. So if you've seen the propaganda out of Fugro recently, the RAMS 2.0 is the latest and greatest. So instead of being a 30 hertz system, it's a 60 hertz. And it's designed for use on a drone system. We haven't used this on a project yet. On a drone, the system is currently installed on an aircraft in Fort Lauderdale. We installed it about a week ago. It's going to go down to the Caribbean, and then we're going to bring it back and hopefully use it on the on this FSMI program. Come on. There we go. So this is set install. So this is what it looks like inside of an aircraft. So it's, I mean, we can put it in a very small aircraft. It's tight with where the operator sits, but the difference between RAMS 2.0 and RAMS, the initial RAM systems, is that it's two lasers. So it's, instead of just one light pulse being shot at, it's two, and that's really the only difference. So what does that look like when we're actually collecting? So we collect this image. We can then interpolate, or not interpolate, we can then interrogate the system to actually pull the waveform out. So you can see the waveform on the right-hand side, which goes along with the that yellow line that goes down the middle. And you can see, I don't know if you can read, but I mentioned earlier there's about 1,000 soundings for each pulse. So you can see 0 on the left-hand side on the x-axis, and then 950 on the right-hand side. So that's how these pulses are split up. And then, of course, we can do some fancy interrogation on these images to hopefully reduce the amount of classification that's going to be required. And as you can see, so it's, I mean, you can give a toddler a crayon and they can hopefully, pick out some of these features. So you can see what topography looks like, and what water surface looks like, and what bathymetry looks like. So we were kind of able to take that and develop some interesting techniques to hopefully go from a previous program with RPM1, which was able to, I mean, it still had noise. Bathy lidar systems have a lot of noise historically, but we were able to take some of that information and get to a point where it was a little bit easier for us to clean data. So immediately after a flight, we don't have to clean out as much. We still have to do some classification and cleaning, but immediately after a flight, we have a pretty good idea of what the coverage looks like without having any manual intervention, which is pretty great. And then the image space comparison from RPM1. So it's really in this near shore environment that this technology really shines. You can imagine the amount of classification. So this is, one image out of 60 every second that somebody would have to go through and clean in the point cloud. But if it's already 90% of the way there, or 95% of the way there, it's a heck of a lot easier for us to actually deliver that to the client in a timely manner. And of course, there's a really hideous one from the initial RPM, and then you can see how it's actually reinterpreted in RPM2. And then we had to go back and do some touch-ups, because as you can see, there's, it's in that nearshore environment, which we really care about, because that's where the reefs are. That's where the shoals are that we actually want to do feature detection. So we had to spend a lot of time there to actually make sure that it was able to pick out those features. So RPM-A and then RPM-2B. And then what does that look like? So I mentioned last summer, we did some target detection with NAVO's 1 meter and 2 meter cubes. We placed them at 5 meters, 10 meters, 15 meters, and 25 meters of water depth. And what you're seeing here is actually the image slice from one of those 1 meter cubes. I believe this is at the 15 meter water depth, or it might be the 20 meter water depth. I'm not exactly sure. But these are the same image. You can just see zoomed in on the right-hand side, the waveform and the points that are placed along the cube itself. And the reason why water surface is on an angle is because the boresight values aren't plugged in. You can see on the right-hand side, they're all set to 0. It's a no-no. And then what this looks like in the point cloud is we have a fairly clean point cloud without having any manual intervention whatsoever. So what you're seeing here is RAMS topo. You've got Bathy. You can see the actual the water surface as well. But the interesting thing, or that you can see is, as we're going through in slice mode here, is you can actually see the shoals and the reefs in the Bathy. What you're also seeing in the red, that's all of the low confidence areas. So everything that's 75% confidence or below, the system's not really sure if it is what it's calling it. So the user has to then go in and make sure that there's nothing that needs to be adjusted. There's other points too that are here. So there's other returns that you're not seeing, but these are what the system is calling these 3 different features. And then of course, it's not just everything is internal to like the Fruga RPM software. We still have to do our INS GPS processing. We still have to do our bore sites. We still have to do all our QC. We still have to do all our calibration. We still have to do additional classification and AT if it's a photo project. So I don't want to come up here and make it sound like we have a silver bullet. We really don't. But this product development is ongoing, and it's a really great advancement that we've been able to make. But we have this workflow that we have to follow through to get client deliverables out the door. So looking forward, we're looking to mobilize in, I said the April-May timeframe. So once that first scanner comes back from the Caribbean, and we'll hopefully put another one on by the time May rolls around. We only have that 40% left to collect, so we're not in a huge hurry, but we know that the May, June, July timeframe is going to be the best seasonality for us to do that. Covered that. So the 2 blocks north and south of Cape Canaveral. The one thing that we are having difficulty with is the Cape Canaveral airspace. Alex Reed was actually really great to physically go there in person and ask for who's the right person to talk to get clearances. Everybody at Cape Canaveral, they're happy to let us in, but it's the SpaceX folks who don't want us taking pictures of their rocket ships from our planes. So that's what we're currently fighting with, but hopefully that'll be resolved by the time we mobilize again. And then the other thing is collecting beyond the 20-meter isobath. So actually targeting those areas, in particular in the Northeast. In the Southeast, the shelf drops off so quickly, it's almost not as worth spending the time there to get beyond that 20-meter isobath. Kind of close to Cape Canaveral, we might see, but we're definitely going to focus our effort in the Northeast for that. And yeah, additional eye candy. So I don't know if we have any time for questions. Okay, perfect. Great. Nice.
Oh, yeah. Jim, go ahead. Digna Roa, do you want to unmute yourself and ask your question?
Okay, it was answered with the presentation.
Paging Digna?
Yes, hello, I'm Digna. I think that my question was
We can't hear your audio here.
Digna, I don't know if they can hear you, so I'm going to ask your question. What is the depth range for the green LiDAR?
So it depends on turbidity. It depends on what's in the water column. With this system, we're able to get up to 30 meters without any significant obstruction. But in some places, we're only going to get up to 5 meters. In some places, we're not going to get anything at all. It really depends on what's in the water column. That's why I mentioned the Northeast is probably the most difficult place to collect in Florida, opposed to the Keys, where you've got really great water quality, or in the Miami area where you've got really great water quality. There's not a lot optically to compete with, and that's the thing about yes, that the green laser is what helps penetrate the water surface, but it's still an optical system. It's not an X-ray. It can't look through hard objects, which sand and silts are hard objects.
Other questions in the room for Malcolm? I had a question. Oh, wait, who had their hand up? Sure.
Thank you for your representation. What is the spatial resolution of this method?
What you're seeing here, this is a 1 meter DEM. So it's a 1 meter grid cell with a hill shade underneath. why it's popping out. But that's what the deliverable is for this project is a 1 meter dam.
Yeah, that was also the recommendation from FCMaP originally too. So good coordination.
For the low confidence areas that are a little deeper, I mean, I assume it's not a part of the deliverable, but there still might be value. Some of that data, is that going to be available?
In having, you mean our confidence values that we're assigning to each point?
Right.
You mean? Yeah, so that's part of the, I mean, it goes into the final last point cloud. So whatever goes to depth is going to have that included.
Yeah, well, yeah, you had like some maps, it looked like areas that dropped off, but you had these kind of reefs or shoals that kind of low confidence, but still might be of interest.
Yeah, no, absolutely. Yeah. I should say, so then in the final product too, I mentioned there's some classification that happens after the fact. One of the things that we do is we actually go and identify where extinction should be. So even though we're seeing points that the system is able to identify as maybe being bathymetry, it gets to a point where it's too sparse to actually be able to put to be able to do any kind of generated surface from. So that's there's human intervention there too.
And I had a quick question at the very beginning when you were talking about the kind of process of negotiating contracts with the state.
Yep.
And that you had to collect, you could only collect further out because of something you called PLS, and I didn't understand what.
Yeah, so in order to collect LiDAR within the state boundaries, we have to have a licensed land surveyors that sign off on all of our work, on all of our flight plans, et cetera. Fugro has that. It took us from the time we mobilized in June, June until the end of August to actually get that contract signed. So to get around that, because we knew we had to expedite the actual collection effort, we said, okay, well, we're going to go and fly, but we're going to fly outside of state waters. And then that way we can kind of get around this requirement to have, I mean, we still had our PLS sign off on everything we did just to cover ourselves. But at the same time, that forced us into kind of a difficult position acquisition wise, because we knew that we had to collect, we were up against the clock. So if you're unfamiliar, there's liquidated damages in the contract. So that's why we were really pushing to have, okay, we need to get this 20% complete and delivered by December 15th, which was our first timeline. So we knew that had to be in the bag, as it were.
Thank you. Anything else? Okay. Thanks, Malcolm.
Awesome.
Hey, thanks, Malcolm. We're pretty much on schedule. So let's move right on to Dewberry, and Emily Klipp will be providing that presentation for us.
Good morning. Wrong way. Okay. All right. I am Emily Klipp, and I am from Dewberry. I'm a senior project manager and managing the Florida Seafloor project, as well as the majority of our topobathy LiDAR projects at Dewberry. So today I will talk to you about our Florida Seafloor regions that we were awarded, which are regions 4 through 6. Starting in May, we were awarded Panhandle and Big Bend, which are regions 6 and 5. And then in October, we were also awarded the Southwest Gulf Region 4 area. So in total, this makes up about 25,000 square kilometers of the Florida Seafloor project. So that's almost half of all of the regions. So really excited to do this work. So we were awarded regions 5 and 6 in May, and started flying in July, August. Not ideal times, but we are under time restrictions for this project, or these series of projects, and the traditionally, the best clearer waters are in the fall and winter in this region. So we started a little bit early to kind of make some headway, and I'll go into some more detail in a minute on our progress there. But I do need to mention, as Malcolm mentioned, El Nino has really been a huge impact on us. We're making progress. I'll show our progress, and I'll go into additionally, our regions that we were awarded actually work well with the projects. We've been doing a lot of topography LiDAR mapping in Florida for the many years now, and since 2020, through our active projects, we'll have mapped over 46,000 square miles of topography LiDAR in Florida. So that's a really great achievement. And I should also note that on this map here, you can see the laser pointer. This area here, so our Southwest Gulf region, actually was a bit larger to begin with, but we were awarded a project through NOAA for the post-Ian topography LiDAR work last year as well, and worked with the state of Florida. We didn't want to duplicate data. We didn't want to fly for NOAA post-Ian and then fly the same area for Florida seafloor. It just didn't make sense. So we worked with the state, and the Southwest Gulf region was then kind of clipped back to just be directly adjacent to that post-Ian project. So we're flying both of those at the same time now. And for most of those topography LiDAR projects, we are using the seasonal supernova, and for Florida seafloor in particular, exclusively using the sensor, and we actually have 3 of them that we're working with. The spec for Florida seafloor was a deep channel sensor that could, 3 Secchi disk depths or better, and the seasonal is about 3.5. So again, that you have to consider water clarity, bottom substrate. If it's more reflective, you're going to get better returns. Darker bottoms, you're going to not get as great returns. And this system has a near IR sensor, a red laser, and a green laser, 532 nanometers, but also has 8 channels. So that's 7 shallow channels and 1 deep channel. So it emits 1 pulse of green light, but then essentially has those 8 receivers, 7 that specifically work for the shallower waters, and 1 that's designed for getting those other returns from the deeper areas. And this is a waveform resolving system. So the Keras software allows us to input different parameters to help pick the water surface and bottom returns from those waveforms and process the data out. So now going into a little bit more detail, starting with Panhandle, and I'll work my way down. So we've so far collected 80% of the Panhandle region. Again, this was the first area we started in July, and also the smallest area we have. So going down kind of these statistics, we've made it through the QA of all of the data that we've collected. And of that, we do have 21% that needs reflights. What does that mean? That means specifically for this project, we want to, we have to make at least 3 attempts. So we fly, we look at the data, we determine where there's no seafloor coverage in the data. And then we want to go back and make a second attempt under, better conditions to see if we can get more seafloor coverage. So we've gone through the data that we have in-house, and of that, we have about 21% that we need to go back and get, for better coverage if we can, hopefully. Some areas this is not going to happen, and I'll give some examples of that where, we will not get full coverage of this entire area, right? That's a lot. We'll get great coverage, but not full coverage. And so that's where the sonar task assignments will come in later to fill that in. So far with Panhandle, we've flown 36 missions and have delivered 40%. And we actually just got acceptance of 20% couple days ago. So, and I'll now this way. Okay, so here is, everyone wants to see our data, right? So, so here's our coverage rasters of the data. So essentially what a coverage raster is, it's a digital elevation model of our lowest returns. So that really gives us a good idea of what's seafloor and what's above seafloor. So it's, we can tell when we're not getting seafloor because it's a higher elevation, that's a little bit different texture. So we can see right here, this is, and over here are big areas throughout, that kind of leads us to, we need to look further there and potentially go back and refly. So zooming in, so this is an area over by Port St. Joe. Just thought this was a really cool, I call this the fish pit. We always like to see things in the data. So, and as also something to mention that you can see here, there's kind of some striping. Again, these are coverage rasters. Data's not been calibrated. It's just been processed out of the system, and we're just taking the lowest return. So this is what we're seeing here. Really rough data, but still great looking. Moving over to Santa Rosa, inlet over by Santa Rosa Island. You can see a really well modeled channel coming out here. So some beautiful data, a little spot of turbidity right here in that deeper channel, but overall pretty great coverage. And last but not least, we'll move over to Panama City area. Again, some dredge pits, looks like, and then the channel area. So again, really great modeled. And this is a 3-meter resolution DIM, I should say. Okay, and then moving down to Big Bend. So this is a largest area as well as one of our most problematics. I think the locals here probably know why. It is, Big Bend. Lovingly will say it's the armpit of Florida. So we have, a lot of, the way the coast is shaped here, we've got a lot of sediment. We've got the Swanee River dumping out a bunch of sediment into this area. And it's just been, along with our El Nino and these winds, it's been a lot of sediment movement and just kind of stockpiling in this bend area. But we are making decent progress. We're about 46% 46% of the data has been collected, flown 77 missions, and have delivered 20%, and that 20% has also been accepted. So going into some pretty pictures here. So again, this is our coverage raster of this area, and you can see a little bit more of those turbidity patches. We've got a really bad mission right here that we will refly for sure. And then getting closer to the coast. So in this area, offshore has been a lot better than closer to shore. And then this area south of the Cedar Key areas has been notoriously turbid. So not only with this project, we also flew a project for NOAA in this area as well, and had issues with turbidity in that particular area. So it's, areas like this where we're working with the state, we're identifying, we're not getting seafloor returns. We likely won't. So again, this is a good example of where there's a good chance where the state will have to go back, and this will be filled in with sonar. All right. And just some really great examples of the data we're getting with really cool geomorphic features on the bottom of the seafloor there. And then moving down to the south, something to point out too is, as Malcolm mentioned, we have the supplemental areas. So you can see we are, this boundary is the 20-meter boundary, and we're getting great returns outside of that boundary. So kind of our plan is to where our original flight lines that cover, within our boundary, they will extend, because it's like mowing a lawn, you have to have those straight lines. So they extend beyond the boundary. So those are the supplemental areas we'll provide first. And then once we get more of the meat of the region that we're working through, then we will extend that and go on to extinction as much, as much as we can.
And last but not least is Region 4. Again, this was awarded a little bit later in October of last year. We've been making some pretty good headway with 55% collected. We've not yet delivered anything of this area, but that's coming soon. We've had 97 missions to date here. And something that, aside from El Nino, that's been a recent issue here is, so Lake Okeechobee has reached its levels, exceeded its levels, and the Army Corps has been releasing lots of water from Lake Okeechobee at both to the east out of the St. Lucie River and then to the west out of the Caloosahatchee River. Excuse me. And so this is, coming straight out to the Sarasota area and really impacting the water clarity in that area. So we're kind of, again, staying offshore and north of that and working as we can throughout the region. So here's just again, a good example of the great features that we're getting, and even beyond the boundary again here. And then moving down further south, this is off of Venice. So just, we're going to see some really great stuff with this data. And then overall, in summary, again, we have 24,000 square kilometers underway. Of that, 60% has been collected. We've flown 210 missions to date. Well, that's to date last week. It's a few more now. And we've got 7% of that's accepted, 20% delivered, and then we've got 9% that we're working on reflights on. And yeah, and we're making progress. I should mention, we are also using, we're partnering with TCARTA and getting some satellite-derived water quality metrics. So every day we'll get metrics from the prior day, so we can use those to kind of, once a front's come through, we can see how things are clearing up and determine when and where we fly. And I guess I do also want to mention, as we fly, excuse me, Malcolm mentioned that, they had flight blocks that they're following. Well, we have flight blocks as well, but our sensor operators, while they're online, they can see the waveforms coming in, and they can see if they're getting those bottom returns as they're flying with the waveforms. And so if they notice that they're not getting waveforms or bottom returns in the waveforms, we can kind of push them to a different block or a different area, so we can kind of make the most out of their time in the plane. And that's all I had today. So any questions? We're done. Okay.
Have time for questions. Is there anybody online? Chris, do you want to unmute and ask your question?
Sure. Can you hear me okay?
Yep.
I was just thinking, some of the areas north of Ankelo Key that you were mapping, there's probably some seagrasses in the shallow reaches that you're mapping. Are you able to distinguish that seagrass surface top from like the true seabed with the waveform that you're using?
Potentially, yeah. I can't say for sure exactly the returns we're getting, but we are. It's a point cloud, right? So while we focus on the water surface and the bottom returns, we are getting returns within that water column as well. So, we will deliver the full point cloud data. So, if those seagrass, are being modeled in that, you'll see it, but I can't speak for certain on that.
Yeah, Chris, you might have to be the one to pull out that elevation or height of the seagrasses, but good question.
Cool, thanks.
I saw that image with the Cedar Key map. Why is it so difficult in the area south of Cedar Key?
Wow.
Sorry if I opened a can of worms.
I'm no expert, but there's the outflow of the Wakasasa River and the Swanee River, and we've got a lot of elevation variation with some oyster beds, and there's just, a lot going on in that area. And I'm sure there's much more other scientific reasons, but yeah, I just do know that it's historically been a really turbid area. I don't know if anyone else in the room can provide expertise on that.
And a little part two to that, because I know Cedar Key
Yeah.
was one of the areas that was
Good.
hit really hard from the hurricane.
Mm-hmm.
So
Yeah.
would that increase turbidity for a longer time? Because they're possibly, dredging out local rivers and there's still a lot of junk literally coming out.
Yeah,
from
well, yeah,
valleys.
well, I'm sure that can definitely impact things. Like I mentioned, last year we had a project for NOAA in that same area, just adjacent to it, more near shore. And it's interesting how the coverage rasters align very well, and you can actually see the turbidity from what we just collected, and then the turbidity area in the coverage raster from that NOAA project. I mean, they almost match up perfectly. So, yeah. Thanks. Mhm.
Other questions for Emily? Going once? Okay.
Thank you.
Thanks, Emily. So we are going to move into our break now. We're a couple minutes early, but we're going to ask everyone to come back by what time? 10:20. 10:20. Thanks. And there's everything is outside in the main area.
Discussion time. Break. Okay. No, I was talking to Ashley. I was chit chatting. Chit chat.
Oh,
I think I'm still recovering.
How about now? All right. Thank you. Yeah, we don't want to drain batteries. All right, we're going to get back into the agenda here. We got 2 more presentations before we go to the open discussion. And our next one is Woolpert. We got Rick Householder.
This is working, right? Okay, pointed this way? Okay, thank you. Good morning, everybody, and thank you for staying for the full firm presentations. I'm Rick Householder. I'm Geospatial Program Director for Woolpert, and we are going to be talking about Region 3. Don't feel bad for us. We only have one region, but you'll see that it's a pretty substantial region. Oh. Is it going? There we go. Yeah, exactly. So I wanted to talk a little bit about Woolpert. So Woolpert is the fastest growing global AEG firm. We started in 1911, and I would say we were doing geospatial before there was actually a geospatial. So we have acquired 9 companies in the last few years, and actually that number has grown to 12. 6 of those companies are actually devoted to geospatial. We are a great place to work. We are a hot firm for over 5 years in a row, and we have a 90% approval rating. We also have a very impressive partnership with a lot of different companies that are well known in this industry. We back up one there. Oh, didn't want to back up. There we go. So just a little bit about Woolpert and the numbers. As you can see that we have devoted a lot of resources, a lot of expense in becoming one of the best geospatial firms in the world. So much of this is devoted to our LiDAR specific projects. Okay. There we go. And I don't think we have to go over this too much, but you see the 6 regions. We were awarded Region 3 back in October of 23. Total project area, approximately 20,000 square kilometers. That has increased substantially since we have reached out and done a little bit more of the supplemental areas. And we are teaming with NV5, our NV5 partners back there. Do you want to wave? Okay. So with NV5, we are reaching that December 2024 deadline of getting all of this awarded. And that has been extended, and that was based on a lot of different conditions, and we'll talk a little bit about that. As you can see, we have over 20,000. Like I said, it's substantially more now. And that really stands out. I mean, we only have one region, but that region is substantial. So how do you take on a region like this? I mean, a region with over this square kilometers, we have to break this up into bite-sized chunks, all right? So when we deliver this data, it's in about approximately 20% at a time for our deadlines. So each one of these have broken out where we have NV5 flying and acquiring in these different areas. We are flying in area 2, which is right up there in the red. And we, as Woolpert, are doing most of the processing for this. So we talked about the bathymetric LiDAR. We talked about, what wavelength is most effective in this. 532 nanometers is what penetrates the water column. This is what gives us our best returns. So for our team, both NV5 and Woolpert, we're using 5 aircraft and 5 sensors in this rather large area. Chiroptera and Hawkeye, these are shallow channel and deep channel sensors for acquisition. And just the flight plan, just to give you an idea of what is involved here. So these are 50-kilometer flight lines. So these flight lines We're doing a lawnmower pattern. We're basically mowing the grass, as we say. These are 350 meter swaths, about 20% overlap. We're flying at about 480 kilometers or less than 15, a little less than 1,500 feet. And there's one of the views outside the aircraft. So this is where we need a golf clap. So we've got about 16,000 square kilometers collected. As you can see, there are some gaps, and the other firms have talked about the gaps. We know that, you know, how difficult it is to acquire in certain areas, but we persevere through this and have collected this since October, a very tight time frame. And as you can see here, back in the right over here in the dried tortugas on the far left, this is where we've expanded out into the supplemental areas. So just a bit about the processing. When you're talking about processing this much, we're talking about actually petabytes worth of data. So whether it be the trajectory process, converting a LiDAR processing to the point cloud, doing spatial and manual LiDAR editing, and then applying geos and offsets. This is very intensive, staff-intensive production that we're doing, months and months of work. But with that, you're getting some very, very good returns as far as the data. And again, we're persevering through a lot of the things that the other companies and the other firms have talked about, and we'll go over that in just a little bit. But Malcolm stole my eye candy comment, so I think we're going to call this Bathy candy, is what you're going to see here. So just want to give you some highlights of what we're able to collect to this point. So Pickles Reef, this is a reef, the very famous dive spot off of Rodriguez Key, and there is a map showing that's just east of Tavernier. Very impressive point cloud that comes out, and I think Alex Reed used this in her presentation. Here's another look at a reef, a coral reef head. You can see how impressive the really high elevation ones are. This one is between Tavernier and Key Largo. Getting really good returns on that. This one is really interesting. If any of you have dove the Neptune Reef, this is actually one of the most popular dive spots. This is off of Key Biscayne. This is an underwater intern area where you take your loved one's ashes and turn it into this underwater cemetery. This is about 45 feet of water. This is what it looks like, you know, as far as the point cloud. I'm actually going to be diving this with some students this summer. This one, it's always fun to find a shipwreck. The USS Spiegel Grove. Spiegel Grove went down in 2002, actually planned artificial reef. And you see, as far as the black around it, that is laser extinction. So this ship is so big, we're able to see that sticking up and actually seeing the outline, seeing the different the levels of it. Okay, that's south of Key Largo. Next one, Dried Tortugas off of Fort Jefferson. This is about 68 miles west of the Dried Tortuga, or Key West in Dried Tortugas. Has anybody been there? Very impressive fort. And obviously this fort is not underwater, but this is one of the advantages of getting this whole area. This is some barges off the artificial reef off of Key Biscayne. So we're able to, again, identify all the shipwrecks. Most of these that we have found, all of these that we have found, these are identified as artificial reefs. They've been charted and cataloged. You can do it. There we go. So geomorphology, this is very interesting where we're seeing these channels. This is just north of Big Pine Key. So the channels, a feature that you can see in natural color imagery, but really stand out when we look at the bathymetric LiDAR. There we go. And as you can see, these even stand out in natural color. Now this one, I don't have a map for. And there's a reason I don't have a map for this, is because this is kind of a special little area. And I think one of the things we want to keep this relatively secret is for what we found coming out of it. Darn it. Come on, go back, go back, go back. Oh, it was so close. Let's see. Can I go back? There is a secret to this. There we go. Okay. So there is the top secret mystery depression. And since it stole my thunder, let me see if I can do that again. That's what we have found coming out of that. So we're going to keep that relatively secret, that location of that particular area. Now, I was told we thought that was fish right underneath the UFO. Dave Neff says that is not fish. And so we're waiting to find out what that actually is. So, Marathon looks so peaceful, so calm. This is, paradise, right? But that belies one of the issues that we have in South Florida. And these are some of the project obstacles that we have encountered. Now, as we persevere through this, these were expected obstacles, right? We're going to have weather, as you can see here. The storms that move across the Atlantic are numerous. Every year we have to contend with those. You're going to always have mechanical issues. You're going to be processing petabytes of data. We're on a very, very tight schedule. Even with the deadlines moved, we're on a tight schedule, and also the natural events. Now, last year, we had a sargassum mat that was almost the size of Texas. It dispersed. We did not have to encounter that. But this is what we're dealing with as far as normal summertime pattern storms. Now, with this is not what we have encountered since October. We'll talk a little bit about that. So I've been down here for about 40 years in South Florida. I live in West Palm Beach. I have never seen a weather situation in the winter months like we've seen this year. So we've had just back-to-back fronts coming through, and every time these fronts come through, increases turbidity, increases fetch, and then we're actually seeing the bottom being, the turbidity increasing and reflecting off the laser. So because of that, we have to wait 2 to 3 days before this settles down and we can actually get a good bottom return. And this is a repeated cycle that we've seen since October. So just to give you some idea of the wind that we are counting, these wind rows, starting in November, we see increase of winds over 15 miles an hour coming out of the northeast. It shifts a little bit towards February, northeast to northeast and northeast, still high. And then as we get to February, we start seeing a west-northwesterly wind, and then wind starting to calm down. So we've also seen a very impressive amount of precipitation. We're seeing rainfall that, up to almost 10 inches, increased daily rainfall. So there was a lot of obstacles when it came to these weather fronts. Now, we all talked about the void polygons. So we're in constant communication with FDEP, identifying those areas, creating polygons, determining what we fly, when we fly, if we're going to fly, several flights over these. Usually we try to go for 3 flights and then determine if more flights are needed. And so this is one of the things that we discuss with FDEP on a regular basis. So as we fly these, like the purple lines we see on the left, those show voids that we will not refly. We've reached extinction in those points. The blue lines on the left, those are areas that we've identified that we are capable of reflying. And the trick here is that you don't want to spend days and days and days reflying. Get to a point where you actually have identified this as maybe a candidate for vessel-based sonar. Again, we see on the left, you make one flight. If we can go to extinction, we understand that that may not be an area that would be flown. So as we talked about a vessel-based, I'll point to Dave Neff here with our vessel-based unit. So these are areas, the voids are areas that might be, again, very good candidates for vessel-based sonar. And that's an area that we're talking with FDEP about these specific things, these specific areas, and certainly beyond the 40-meter into extinction areas that we'll be looking at. The one thing that we have identified through Bathy LiDAR is we can pick up dolphins. And I don't know if you guys know this, but we've been able to identify a specific area where dolphins are very prevalent. And that's the area that we picked up. So all you Bucks fans, sorry. So overall, we're very pleased with the progress that we've made. We continue to fly. Like I said, we have 16,000 square kilometers that we have flown. The weather is getting better. We feel that in the next couple of weeks, next couple of months, we're going to be able to knock out, everything that we had planned to do. So with that, open up to questions. Okay.
Okay, we'll start online. Are there any questions for Rick online? Okay. Everyone's talking about the
That
blue
UFO, I got to keep it secret.
I have a follow-up question to that. How big in circumference approximately is your UFO?
It's again classified. That I believe that is about 50 meters across on that one. So yeah, more details to come on that.
Questions from the audience in the room? Wait.
Oh, that hole gets
Everybody
a lot
wants
of
to talk
attention,
about
doesn't
blue
it?
hole.
How many passes did you make before you identified that it's special?
That was a relatively easy one. I think we just made a couple of passes on that. That stood out. That definitely stood out. We did not have to go through many reflights to identify that. That was in area 2, by the way. I won't keep that secret. That was, well, I don't want to go back and go through that again, but it was one of our first areas that we encountered.
Renee has a question.
So I think this is probably the biggest issue in the Keys, but natural or cultural resources that are sensitive. Does the Park Service or anyone indicate what you should be making less?
No, we haven't heard anything about that as far as the sensitive areas that we shouldn't be flying. Not as of yet, anyway.
Got it. No galleons, Spanish galleons, they're hiding from us?
Well, we're looking. We're looking. So you're talking about something like the Etosha. Yeah.
Great. All right.
Anything else? Okay, thank you.
All right, we are staying right on schedule. Thank you. We're going to move now to Sail Drone, and we've got Brian Conan here.
All right. Well, thank you for allowing me to come up and talk to everyone. We're not mapping yet, so I'm just going to give you an update on the vehicle we might use down here and how that's going for us, and also talk a little bit about USVs in particular and some carbon avoidance studies that we've done. And then I'll put on my hat as the Hydrographic Society president and give you a quick update on where we are with that. So So just a little bit about Sail Drone, who we are. I think you all are pretty familiar with us. Hopefully, if you were over at the hub last night, you got a chance to look at one of our hurricane drones. If you have any more questions about that, let me know. 3 mission areas for us: maritime surveillance. Currently have about 15 drones working in the Caribbean, doing Navy, Coast Guard, and Border Patrol operations. We do ocean data collection. So we're out collecting climate data, and the drone you saw on the pier over there, the hurricane drone, is part of that mission set. And then there in the center is our ocean mapping mission, which is what I'm responsible for. So just a real quick on what the Voyager, which is our mid-size vehicle, 10-meter platform, what it looks like and what we would bring to the fight here in the Florida mapping campaign. Here's a picture of it up in the Gulf of Maine. I'll show you some data from that shortly. So again, a 10-meter platform does have the Norbit I-80S as well as an AML3. But it's a special AML3. We have 500 meters of line on the back, and the AML3 is inductively charged when it returns to the cradle. So it does not become a limiting factor for us to have our CTD need to be recharged. And then the game changer for all of us working in the offshore space with USVs is Starlink. And so we're able to move full resolution multi-beam raw data back ashore daily for processing now. So that's kind of a big deal. But you can see a lot of solar panels here, but the radar, AIS, the sonars, compute stack that we're running on these does necessitate having an electric generator on board. And so if we have no wind, we do have a torpedo thruster that allows us to still continue surveying even in light winds if needed. But we really like to sail because that's what gives us our endurance. So for this vehicle, we're looking at about 90 days of endurance, longer if we don't have to use the engine that much. Again, a little bit of background on the wing. If you saw the wing over at the hub last night, it looked different than this one. This is a standard wing for us. This technology was built and came out of our boss having the world record for speed in a land yacht out in the desert in Nevada, which he set, actually, I think it was 11 years ago yesterday, maybe, where he went 126 miles an hour in a land rocket, if you will, and then took the technology to sea. But it's essentially an airplane wing. If you were to take this wing and flip it horizontally, it would look a lot like you would see looking out the window of your airplane with a trim tab in the back. So the wing is freely rotating. All we have to power is that small trim tab in the back. So that's how, again, we can get away with having such a low power vehicle to get the endurance that we have. So this areas we've been working up in the Gulf of Maine. A little hard to see there, the resolution. A lot of trawl marks up in that part of the world. All of those kind of balloon-looking icons that you see, those are our sound velocity casts. So this is a capture from within our mission portal. So that allows you to see the coverage that we've gained. You can click on the sound velocity cast like I've done here and get some info about it. You can further click on it and actually see both the up and the downcast within the mission portal. So both our hydrographers and our customers have access to this 24/7 to be able to go in and see what the drone is currently doing and kind of a time series history of what's going on. So maybe. Obligatory pretty pictures. No Bathy presentation would be one without it. You can see some of the backscatter we've collected up in the top as well. These Norbits you can have them calibrated at the factory for backscatter. So again, just an idea of the kind of data. But if you look close and just look at the marks on the bottom up in the Northeast, a lot of years and years of fishing up there have really damaged the bottom. But this is what we're really excited about. So this is our new sail drone surveyor. So this is 65 feet long, outfitted with Kongsberg EM304 Mark II and the EM2040. Has the same AML3 winch in the back, POS-MV integration, Starlink. Again, these are the ones that can go out and do the remote deep ocean mapping missions. Prototype we used over the last couple of years went all the way to Hawaii and back, and then up to the Aleutians, collecting data for NOAA and BOEM, among others. So we're pretty excited to get this EM304 Mark II out there, which should give us, as we all know, the the text sheets from the manufacturers are all truth. So we should be able to get to 11,000 meters with this sonar, which we hope to test next year out in the Marianas at GO. But we're testing the first one of these now. We're building these at Austell, USA, big shipbuilder there in Mobile, out of aluminum. The reason we did that was the first one we built out of composite took a really long time to build, and we want to be able to scale up. And so we have the next one of these will be coming online in the next couple of weeks. We've got 5 in the first order. I suspect we'll be adding at least another 5. So by this time next year, we should have 10 additional deep water survey capable USVs added to our capacity out there. So pretty exciting stuff. Just a little bit on the specs of what's out there. Again, we're looking 90 days plus for these types of vehicles. This one doesn't have a diesel generator. It actually has a Yanmar marine diesel engine, 78 horsepower to do a drive a sail drive, but it has the BSGs to allow us to charge the batteries. So again, the more we can sail, the less we have to run the engine for actual propulsion, the longer we can stay out. But, why USVs? And I have a whole list of things here. And I think as I was listening to Alex Reed's talk today, talking about getting the acoustic things on contract by December and then finishing everything up by December of 26. So 2 years to do a whole lot of mapping in very shallow water. That is going to be very difficult to do. Now, it could be we just map until the money runs out, so it may not be the whole area. But what USVs bring to this is the ability to scale up to meet that. Because I can tell you, folks are planning their schedules for their USVs far enough out that if you all of a sudden you're awarded in December, you may not be able to start executing on that until summer of the next year because maybe your assets are tied up, right? So, that's up to us as the companies to decide how we're going to either hold off and wait and hope we get a contract in December and not booked work for our vehicles in January timeframe, or for us, we look to scale it up. So scalability is really a big thing for us. Obviously, the safety factor, you're not putting any people out there. They are very efficient. And the persistence is really a big thing. If you can stay out there for long periods of time collecting this data without having to run back and forth to take care of people, that's a good thing. What I'm going to focus on now kind of is this environmentally friendly piece. And here in the US, we talk a lot about it. We make ourselves feel good that we talk about it. But in other places like Europe and the UK, they're actually doing things about it. And so this will come to us eventually. So I think it's important to kind of understand what we mean here. So normally, when you're doing especially deep water mapping, you're using some of these typical vessels here. You got NOAA ships and Navy ships and research vessels and exploration vessels, all burning diesel, all with people on board, all generally staying out, 30-ish days. So I mentioned we did a mission up in the Aleutians. So we went up there and between the Aleutians and some work off of California that we did for OER, we mapped about 45,000 square kilometers, found a cool seamount, which is all really good stuff. But then we said, all right, so for the Aleutians piece, what if NOAA had done that with one of their ships? And we contracted a company called Right Ship, who basically takes the burn rate of ships and they actually kind of comes up with the carbon avoidance for us of had we done the work. So in this first case study, of 16,250 or so square kilometers mapped, kind of did an average of the Rainier, the Fairweather, the Okeanos Explorer, and the Hassler, saying, hey, those would likely be ships that could have done the work that we did, and then based it on had they covered the same area as us. Now, for us, we optimize for the wind. So our survey lines tend to change because when the wind shifts, we change our lines to maximize and optimize our speed. For the ships, we did it as a normal ship would do it, kind of straight lines across the whole area. So anyway, the NOAA ships, depending on which one it is, you can see their emissions kind of ranging there from almost 250 tons to over 600 tons. But the bottom line is we at about 10.5 tons. So you're looking at a 97% carbon avoidance by using USVs to do mapping. Now, I'm not going to go drop an ROV. I'm not going to launch AVs. I'm not going to do big CTT rosettes. So I'm not saying we don't need the ships. I'm saying that we don't need the ships necessarily doing all these really, kind of tedious mowing the lawn, which was mentioned earlier, missions. So we thought, okay, so that's against the Surveyor. That's against our big vehicle. So then we looked at a mission that was done by the Thomas Jefferson, transiting from Norfolk up through the St. Lawrence Seaway into Lake Erie and knocking out a few areas in Lake Erie, as compared to had we put a couple of Voyagers on a truck and sent them from California up to Lake Erie to do the same mission. And again, kind of similar results where almost 99% carbon avoidance by using these vehicles. So I haven't really, talked about cost comparison here. This is really just about the carbon for it. But as you can imagine, the costs are likely less as well. Although trying to pin down what a daily rate for a NOAA ship is even Larry Mayer can't do it. He tried, and that's something it's really hard to say. So trying to do a comparison of daily costs doesn't really work. But at least on the carbon side, we know that these USVs can help achieve some of NOAA's net zero carbon goals. All right. Okay, so that was it for Saildrone. Hydrographic Society of America. If you don't know what that is, then you should come talk to me or Rachel later. So Rachel's on our board of trustees. And I've been president since January 1st. And we're got an all hands actually coming up tomorrow in the afternoon. And I'm going to go through some of our membership survey results, put out a poll asking people what they thought and where we should have the conference. All those things. We will likely announce the conference location tomorrow, but I'm not going to do it today because I want you to tune in tomorrow. We will have an update tomorrow also from John Dazzler from David Evans. He leads our certified hydrographer efforts, and he's going to talk a little bit about where we are with the certified hydrographer process in our relationship with NSPS. If you're not a member, I encourage you to join, whether as a corporate member or as an individual. We're really trying to support our hydrographers and start really taking a look at these as requirements come in for certified hydrographers. We're starting to see that more and more as a requirement on projects. If you talk to someone who is a certified hydrographer, they're finding it painful to get professional development units. So for the academics in the room and for companies in the room as well, it would be great if we could have a conversation about how do we build more professional development opportunities for our hydrographers. Because I would like for us as the Hydrographic Society to actually be able to help you stamp something and say, yes, this qualifies for 8 hours of professional development or whatever that is. Right now, it's just kind of an honor system. You send in a spreadsheet and says, yeah, I attended this webinar and it was 8 hours. Okay. I'd like to make it a little more formal than that and encourage folks to actually participate in. And people ask me, well, what about if HYPAC gives training? I'm like, well, if you're a hydrographer who uses HYPAC and you go to HYPAC training, that's professional development. So I have no problem with companies providing training, and you get a little bit of advertising on the side as well. That's okay, as long as there's good content for the hydrographer in there. With that, I'll take any questions.
Okay, I don't think we have anybody online. Anybody in the room, Rick?
Yeah, Brian, you're obviously pushing a lot of data through the Starlink system. Is there a bandwidth maximum with the Starlink network?
There is. I could say we're seeing about around 80 megabits per second, I think is what our engineers have told us. So it's a good pipe. I don't know if anyone else in the room has been using it and can say, is that what you're seeing, Dave? About the same. Yeah. So, we also have Iridium Certus as fallback. So if Starlink fails, or if Elon jacks the price up, now that he's got us all addicted, then we can still do command and control of the vehicles over Iridium.
Other questions for Brian?
I have a question regarding the Hydrographic Society and the Certified Hydrographer program. With more and more of other technologies beyond vessel-based sonar being used to measure the sea bottom, any thoughts on how that certified hydrographer can extend beyond that? Or maybe I don't know enough about it, whether it does right now.
No, that's a really good question. And we could have a whole nother day of talks on what a certified hydrographer means. Can that certified hydrographer sign off on your Florida mapping project? No, it has to be a professional land surveyor, right? And that's because we don't have a national recognition of that certification as being someone who can sign off, right? So you have to get on the state level. And so that's been kind of the rub of, hey, why do I need to get this if I can't even sign off on the work that I do? And that's a great question. And so that's something we're looking at. But to your other point of other things, right? USVs, LIDAR. So some of those things are included in the exam, not a lot. But I think that's where micro-credentialing comes in and professional development units. So like the University of Southern Mississippi runs, a 6-week course on UUV, basically, operations and maintenance kind of thing. And so you can go over there and they call it an Unmanned Maritime Systems Operator course. And they have 2 levels up. We're working on a 3rd. So I think that's opportunities for us as hydrographers to get smarter and better trained or educated on those things that are outside of the normal path. I always look at it too as the International Hydrographic Organization has their standards for surveyors, Cat A and Cat B, but those are pretty straightforward. You will use a sonar to do this, right? They touch on some of the other stuff, but that's because you have to kind of go with the lowest common denominator out there, which is a small country who's just starting out as a hydrographic. If they want to have their surveyors IHO certified, they don't need to know all these things because they can, they may have a boat and a single beam and a side scan. And so it really comes down to, for us as a, well-developed country with lots of companies doing hydrography and doing fantastic technological advances, we're going to benefit from it, but, it's going to take a long time before the IHO comes up to speed on that.
Other questions for Brian? Okay, I think now Renee's going to lead us in a rousing discussion of the FSMI.
All right, we're now in the discussion section, and I'm gonna just come down for this because it's more about you guys. I'm just moderating. And you know what? I will ask Cheryl if you don't mind, so we can keep the discussion flowing a little bit, help me organize who's, next. So the intention here is to provide an open forum here, soundboarding, to ensure that we get feedback from the potential end users. Also opportunity for feedback suggestions for the next round of data collection. So again, this is open. We have at least about 20 minutes, up to 30. I don't want to limit us to that discussion, but this can be an open forum for bringing up whatever topics we think. We have a good group here together. We wanted to take advantage of the opportunity, having this expertise in the room. So we have at least 20 minutes. I hear we can go a little bit over if we need to. Who would like to open up? Or is there anything? Did we miss any significant updates? I think we got a pretty good overview. That was very informative. Having seen now what's been collected, we're starting to see this data is going to start coming online here soon. There's been accepted products that'll be coming up. We have an idea of what's being done here generally, how collections are working, acquisitions. Any feedback on that? Yeah, we'll go online. Chris, do you want to unmute yourself?
Thanks, Rennie. Yeah, a question about the status of the LiDAR collects that are going on, particularly in Southeast Florida. We're planning some multi-beam collections and surveys 20 to 60 meter depth range to map the outer reef bar, and wondering if the LiDAR collects could be available in at least coverage footprints or otherwise to show where we could junction or overlap what will be concurrent data.
Question. Would anyone, any of our industry?
Wolpert? Wouldn't that be Wolpert? No, that would be Fugro. Fugro? Okay, we'll table that question until Malcolm returns. He just stepped out.
Yeah, sorry, Chris, we'll get you to answer when he's back in here. We'll ask him that question again. So I know there is definitely an underlying consistent theme here that it's been a tough season with the weather, and challenges are, I think everyone in the state is facing these same challenges with the weather, but it seems like the acquisitions and most of what's being collected is looking good. We hear windows, there's tight timelines on getting this data collected. And I did have a question as an end user, if no one wants, I can get us started here. So I'm going to ask as an end user, put my Fish and Wildlife hat on, never really took it off. The habitat is something that we're obviously very interested in. And I know that often imagery is collected while you guys are up in the air. That can be really valuable ancillary information if when we're trying to classify bottom type. How is that? I know you guys have obligations to deliver DEMs. Are there any plans or will imagery be available? Are you guys taking aerial photography while you're up there? No?
Anybody taking aerials?
Oh, and this is so the online people can hear.
Imagery itself, or of the LiDAR itself, as part of that whole package.
So let me follow up. Will you have, that's not a deliverable to the state?
That is not a deliverable.
Will you somehow make those imagery, the imagery available for end users if they need them?
That is something we'd have to discuss with FDEP,
Okay.
see if that is available, and put that out in a product that could be useful. And I don't have an answer for that. It could be.
I would add that this is because the collection is all based on getting the best possible LiDAR in conditions that could have cloud cover, could have other aspects, and we are flying really, really low compared to typical imagery collects. Using imagery especially for habitat analysis and things like that, would be, with caution, is a recommendation, and also that it is. We fly at any times as well, including late in the evenings and in the night. So those would be factors that you would want to consider as well.
Good points, yeah. All right, I'll make my way back. And keeping in mind, satellite imagery is also could be a valuable tool for what I'm asking about.
So along those lines, are you all creating intensity grids for the LiDAR collections?
It's not a specific deliverable to provide, intensity rasters is something we provide for NOAA and USGS and others. But, those intensity values are stored in that point cloud format, which is a deliverable. So inherently not specifically no, but it is there. So it could be obtained from that.
Just a follow-up question. So you guys are using 3 different LiDAR sensors, 3 different platforms. How do you see creating seamless products for intensity across those platforms? I'm looking at you, Emily, but anybody can answer this question.
Is Jeff here? Oh yeah, Jeff. Want to comment on that, Jeff? So the question, it was regarding, basically the backscatter or well, not backscatter, but the intensity data that are not a deliverable to the state, but they're being collected, and they're being collected by 3 different sensors. Is there a plan in place to create a seamless intensity product?
I think the answer is pretty easy. Not that I'm aware of. Obviously, we're involved in creating a seamless DEM of the elevation data, but that other aspect, yeah, that's actually a question for Florida DEP, I guess. That's not, I guess, in my purview.
I'll just follow up. I don't think that that's anything that is going to fall in the purview of this particular pot of funding, the seafloor mapping initiative, because it's pretty straightforward what the legislation says is, to do. From my read of it anyway, that is certainly something that I would advocate strongly that as a stakeholder group or different agencies or firms or whatever, we potentially go after funds to be able to get that done, because that would be a really valuable product for the state or for any entity that wants to do follow up, but actually develop habitat maps, right? So comment on that? So what are you guys, I'm going to ask a couple questions here. This program now is a pretty unique program for across the country. I only know of one other state that has systematically been, collecting data, bathymetric data. That was California's push. It took them about a decade. They used a lot of vessels. It was before LiDAR was necessarily readily available in the early days. So it being unique, how can we, I don't know, how can we benefit from that? Or what are your comments on being able to participate in this? And where do you see it going into the future? Or where would you like to see it going into the future? I guess that's mainly directed at some of the vendors, but if other people have thoughts on that, it'd be interesting.
This is completely off the cuff, but I mean, if we want to accelerate the program, get more funding for the program, we're going to have to show value for the program, right? And so I would challenge the group to be able to show ROI, visual deliverables. Politicians who fund these programs like to stand in front of cameras and say, we did this, and this is a visual that explains it, in a picture, not 1,000 words. I don't know what that is, but we want more funding, we have to show value for what we're doing already. Pretty simple.
Yeah, I think that's a valuable point.
Yeah, I just wanted to add to that, just like peninsular LiDAR, you can't rest on your laurels. It's you can't just collect one time and then shelf it and expect good returns on that. You're going to have to start a program that has regular collects, whether it be peninsular LiDAR, terrestrial, or a bathy. Things change all the time, and refreshes are extremely important in this industry. So whether it's a 5-year interval, whatever, some cadence to refresh this, the bathy and terrestrial is extremely important, especially for a state like Florida that's experiencing so much growth.
So on that note, that gets to the temporal, issue of data collection, and it's unlikely that every 5 years this Florida legislature is going to come up with $100 million for mapping Florida's coastal waters. We can pretty much guarantee that. And so, given that, and given that the majority of the change likely happens in the shallower water, right? Wouldn't it be, and that most of those data can be collected with topobathy. It just seems to me that there should be, again, I don't know if Jennifer's still here, hiding back there. Yeah, so again, her program, does every 5 years, and they do 500 meters on land and 1,000 meters off the coast. Can we work together somehow, state, federal, private partnerships to extend that program to bring it out, not just to that 1,000 meters offshore, but, actually get it full on out to, that 20-meter water depth. I mean, that would be, because it's already done, your group has already established a sort of protocol, standard protocol. But do you care to comment?
So I think the short answer is yes, we can probably put something together that where we can all work together to accomplish this type of effort once every 5 years. But I would push to do this whole kind of what I'm doing with National Coastal Mapping Program is using our first 3 circles around the coast of the U.S. to establish trends and show which areas are changing the most to try and identify targeted areas that might need to be mapped more frequently than others. So, if I were Florida, I would want to do this 3 times and then $300 million or something. So that might not be within the realm of possibility. But, from a looking at trend standpoint, I'd want to do it at least 3 times to see which areas are changing the most and then establish something after that. So.
Well, this is getting further and further away from Renee's original question that was more around habitat mapping, and that was great, Jennifer. Thank you. Is the way that the best way to go about that, given that we're not likely to get 300 million more in mapping, is can we somehow use these data and choose priority areas? Right, identify those, and then what is that priority? Is the priority human population centers, right? Dense human population centers? Is it sensitive habitat? Is it areas that are changing the fastest just because they're changing the fastest? I mean, what would be the criteria for establishing priority areas? And I think that is a topic that would be ripe for a full-blown discussion amongst this group, and obviously getting feedback from federal and state partners. But if anybody wants to comment on that.
This is just another off the cuff off what this gentleman just said is it's the tourism. I mean, any politician can sit there and utilize any of these images to promote the keys, to promote the diving and the keys, to promote education. And that's a no-brainer. I mean, it's bam right there. And just little pieces can be flown into bigger projects, but that's one place to start. And you can even do it on the West Coast, even though it's a little flat, but it's still, people like to see what's underneath the water, and it makes them less afraid as well. And I only learned that from a family member. So once you show them a map underwater, they're like, oh, that's what it is, So just little things. As I know it sounds so stupid, but it's real. Just little seeds for a politician in the different cities, and using these images that they could show on the news, they could show to somebody. That's huge. There's your 1,000 words right there.
So I'd add on that maybe this is a challenge to the vendors who are collecting the data. I don't think it's a big lift, and this would promote you guys, right? Is to develop a really cool story map, for the areas that you're assigned to collect, and I think that is just a really strong communication tool. And I've never developed one, but I understand that the hardest part of that lift is pulling all the content together. Well, you've got the content, and that way the story could be told. And I also want to follow up, Nancy, with your comment on, it's just, the West Coast, it's just flat. We're actually seeing from what Emily showed today, it's not just flat. And that's cool. We're finding that out. But I would challenge the vendors to consider, even if you're doing it sort of as in kind or whatever, that I think that would be beneficial. And then you can post it on your website and blast it out on LinkedIn and all those sorts of things. So if anybody wants to comment on that, I'm happy to.
Yeah, those are good points. And I think Christy or Kat, you guys are taking notes so we can capture this, right? And point at us if there's, I don't know, are there any online questions or comments at this point? Okay.
Yeah, I was going to add, back in 2017, we at Dewberry had done a Florida statewide LiDAR assessment. And this was not only to look at topographic LiDAR, but also nearshore topobathymetric LiDAR. And I remember being involved in that study, and we'd done it for the Florida Geological Survey, and, lots of benefits and uses and ROIs and things like that. Since then, we've actually had significant collections, both on the topographic side as well as now with the topobathy. it would be really good to do a similar assessment, that's now a little dated. It's about 7 years old, to do a similar assessment that really now that we have the data, what have we been doing with it, and doing, more of an analysis with that. I think that would be pretty significant in terms of ensuring we also have the continuation of the funding that's enabling this as well.
So would it make sense for a coordinated effort on, if it is a story map, which might be the best medium, rather than having just all, everyone individually doing something and then bringing it to a level where maybe FCMaP can host the story and tell everyone's story, individually at the vendor level? Okay.
I think there's pluses and minuses to that because each of the three different vendors, right, they're collecting data in very different areas and they're speaking to different stakeholders, potentially, right? And so you might be able to tell a more compelling story by showing, if someone's really interested in the Keys region, for instance, it's where they go to fish or dive, or that's where they're most interested in, then they could just go to the Keys one. I don't know. It just seems to me that I like having a coordinated one just to tell the whole story. I mean, I think that's great, but I would also think it would be useful for the individual regions to develop one as well, because they do tell different stories. Like, it isn't all just flat out there on the West Florida shelf. Yeah.
Well, I think, speaking from, I think, a vendor perspective is that we're collecting data and our customer is DEP, right? And so the stakeholders, you've already talked to them in your prioritization. So you probably have the best foothold in knowing who would be the most interested in these different areas. And so once the data is available and released and we start seeing user stories, those are where it's really going to make a difference. I think from, at least from my perspective, as we're collecting the data, yeah, we'll have some nice, pretty pictures. We can talk about how great sail drones are and, we should use more of them. But really, it's got to be those end users who do something really cool with the data to make that compelling argument.
I would add, it's all about the use cases. So if we can come up with, I like the idea of maybe FCMaP taking that sort of that ownership, because it's then independent of any specific organization or even vendor, and focusing more on the use cases, because that's really going to show the value of the data.
And I think, I don't know how and if, and then maybe if the vendors, I know you have weekly discussions with FDEP, but that's over the existing, how your clocks are going and all that kind of stuff. But I just say a concern that might be a little strong, but is DEP or is the FGIO going to, with a loud bang, like say, look at all this great stuff? Because I mean, to date, they haven't really been broadcasting and it's not, well, I don't think it's widely known to Floridians that there's this ongoing pretty amazing data collection effort that is going to be beneficial to multiple different sectors and applications. And so it might be on us as a collective body to be the ones that, jump up and down and scream and yell and say, hey, look, this stuff is super cool and we got to keep doing it. Anyway, yeah. So I agree that FCMaP kind of playing that sort of role, but continuing to be the cheerleader. And any thoughts, anybody on anything?
I think I'm just stating the obvious, but FCMaP probably needs to formally create a program, competition, give us case studies. The way Esri does posters at their trade shows, show us use cases, because you say the public, why would they care outside of a pretty picture? They don't even understand what LiDAR is, let alone how to use it, right? So if I can put it in my system, go fishing, right, and find reefs that I didn't know existed, that'd be great.
So it seems to me that this is starting to formulate itself into almost a public communication workshop, right? Where we actually, I don't know, somehow, maybe Renee, we travel the state again. The way we did when we were first introducing the whole concept of FCMaP and host local workshops, showcasing the data and the interesting things that you can do. I don't know, I'm just, again, off the cuff, so.
Yeah, I think one thing is really important is we have a lot of GIS, local GIS conferences and expos. We have one in West Palm Beach. We have the Seven Hills in Tallahassee. We have Central Florida. All of the vendors, there's an opportunity for us to show what we've accomplished. And that gets out to the GIS and the geospatial community, and then that's kind of broadcast up to the other parts of the agencies. So I think that's a really good forum for us to start distributing some of these really cool things that we've produced to this point.
Yeah, and there's also the Florida Society, FSBPA, so the Florida Society for Beach Preservation Association. They have 2 a year, and so that would be another good one. And I think that perhaps FCMaP, maybe rather than traveling the state, on our own dime, right?
ASPRS is another one.
Oh, yeah, ASPRS, where they have that twice a year in Apopka. We can kind of come up with content, I think, yeah, and just actually propose sessions, right? So each one of those conferences we're talking about has a session on the FSMI/FCMaP, use cases. So, yeah. Good. This is good. We're getting somewhere. I mean, we need to.
Yeah, highlighting the value and importance of this data, definitely. I will ask this question one more time just to make sure we got feedback on it. Does anyone have feedback or suggestions for the next round of data collection? We specifically wrote that. I want to make sure we capture anything.
Yeah, I'd say as a potential vendor in this, I think this whole process kind of didn't include one potential technology for coastal mapping is satellite derived bathymetry. It was not in any of the specs anywhere, and I think that there's great potential there for the repeatability and the cost effectiveness of that technology to help the future next versions of FCMaps.
Yeah, thanks. Just kind of a quick follow up on that. I think satellite derived bathymetry is coming a long way. I mean, it's really starting to explode. I think when we first were contemplating the whole program and giving recommendations on specs, the satellite bathymetry wasn't quite there yet. But I think it is there. So point well taken. Yeah.
I think you had a follow up. Did you have a follow up?
Do you have a follow up?
Yeah, I would just add that, as I would say the US based industry leader in this technology, our opinion wasn't solicited for how this technology has been evolved in that. So that might have been useful information in planning this program.
Sorry, we didn't mean to leave you out. No, I mean, yeah, I think, I've heard sprinklings of that conversation around. So that's something. In your experience, what is the deepest that you can achieve, fairly accurate bathymetry with satellites? Because I know they need clear water, obviously. Okay, no, sorry, yeah.
So yeah, we'll hear more about that then.
Thank you.
Check in online real quick before we wrap up.
Was there a question or she's just looking into it?
Okay, so I think we are at the end of that discussion, and we'll move on now to what do we have next? You get to take over.
I'll end up wandering around with this thing. So as came up a lot yesterday in our discussion, at least on the West Florida, let me get this put in. Yeah, okay. when we were discussing the West Florida prioritization, everyone was saying, well, it'd be really nice to see the gap analysis and, you know, where there's data and relative to what the priorities are. So as promised, I was just going to run through really briefly. I literally got these images and statistics late Monday afternoon, so I have not had a lot of time to do any real deep assessment of them, but I'm going to share them with you. Issue? Okay. And so I do want to acknowledge Kathleen Young with NOAA really did a heavy lift on compiling all this for us and running the statistics. So we definitely need that. Oh, and I can move this, I think. Yes. All right. So in the 2023-24 gap analysis, she omitted areas that are contracted. Now we realize that there's a chance that not every pixel, every square kilometer of this grayed out area will be collected because we know there's issues with time and weather and sensor capabilities, et cetera. But for the purposes of this gap analysis, we just said, okay, that area is going to be collected. We're not going to consider anything in the 0 to 20. We're going to assume that everything in the 0 to 20 meter water depth is collected, all right, or will be collected. And then we also pulled areas where we know there are existing data collects that have happened. And those are the areas in white. Everything in green is where there's a gap, where there's no modern high resolution data. So you can see that although we're making progress, there's still a lot of real estate that hasn't been mapped, especially good old West Florida shelf and a sizable chunk of the outer portion of the Northeast region. This is just now, it's so washed out, you can't even see the outline of the state, but this is just now that the green areas, right? So this just kind of is another way of looking at that without the FSMI highlighted on it. And this is showing the gaps relative to that 20-meter isobath. Again, we're looking at the FCMaP regions, which this, sorry, this is a very confusing figure. I told you I just got it and I have because from the looks of this, it would say if this is FSMI region, then that would look like this is an FSMI region, but that's a region that's been collected. So again, I think this is just another way of looking at areas that have data, whether they're for whatever reason, areas that don't have data, which is the bright green relative to the 20-meter isobath, which means, again, yeah, it just highlights how much of the West Florida shelf and the Northeast outer shelf have not had any data collects. And again, there's not much here, so I don't have a ton of content. I certainly won't fill this whole time. I wanted to look at the statistics because that's what helps me. Looking at maps is great, but I think statistics speak. They certainly did when we started this program, when we did our first gap analysis, and we're able to show that only 20% of the entire 0 to 200 meter water depth zone in Florida had ever been mapped. With modern high resolution technologies. And now we're up to 34. So, I mean, well, that's offshore and almost 99. Again, that's assuming the FSMI completes the entire 0 to 20 meters. That might change. But you can see that, we had areas of, like, for instance, the Big Bend that I believe, well, I don't know why I'm saying I believe here. If you look at the Big Bend near shore, this was our original, this was the original gap analysis that we completed in 2017 before our very first stakeholder workshop. And then this is the 2024. So you can look at these numbers. The Big Bend near shore only had 3% of it data collect. And now we're estimating that will be at 100% or close. Other areas, the shelf, only 18% of the shelf of the West Florida Peninsula, it's up to 16. So, I mean, you can see, I just love looking at this and seeing the significant progress. 20% of Southeast Florida is now up to 64%. This isn't just FSMI. This is also efforts by, a lot by NOAA, by Army Corps of Engineers, even in some cases by BOEM. And other groups, College of Marine Science even. So, there's been a lot of parties contributing to this. But, I think that this can be, used to show, look, we've made this progress. We can continue to make progress like this. So that is really all I had. It was really brief, but I'll leave the stats up and see if anybody has any, want to have discussion on this, comments, questions, suggestions. Whatever, it's our time. It's our time. It's helpful that this will all be posted, or if it's not yet, it'll be posted on the FCMaP hub. And you can, with the data, with the existing data collection, you'll be able to, find out the metadata from those, just so you know where to go to get the data if you want it. But yeah, we want to showcase those areas that I think I'm going to speak to a comment that Steve Morowski made yesterday, and he's not here today, but that, in some of those giant regions of the West Florida shelf, maybe there are a few like lines, few lines through here, but, there's vast areas that have absolutely nothing. And even just running a couple, a few crisscross lines through those, or using vessels of opportunity to collect a little data, just so we kind of have a sense of what's out. Is there anything out there? Is there some particular region that we should hone in on to add to our prioritization? So again, yeah.
Yeah, I think that's an important point. The percentages, the statistics in that table can be a little deceiving. We don't want to make it seem the offshore area is a bigger portion of what's still. So there's still a lot of effort that needs to be put out there. So I just want to make sure we caveat whenever we put this, if we put this kind of information out, that
right. That there's a heck of a lot of the 20 to 200 meter water depth that hasn't been mapped. I mean, 16%, 34% overall is pretty low. So we need to keep going.
online question. Kat's going to read it.
Christopher Smith said, sorry, it has probably been explained at some point, but in a previous slide, there were two different tones of gray, one mapped by, he said SMRI ? But some other areas were the other color of gray outside of the areas in water less than 20 meters. And also he was wondering, oh, this is a different person. That's Chris Taylor. That was Christopher Smith, and he wanted to know what are those gray areas.
I'm not quite sure I got what that was.
Yeah, you have. I think what we're looking at
That's the
here is
coastline.
the shoreline.
That's the
Yeah.
shoreline.
Yeah, so that's actually land, is the light gray is land. And the darker gray is is underlaying that.
Yeah, the darker gray
For mapped areas, yeah.
is areas that have been mapped, yeah.
And Chris Taylor, you can unmute yourself. Had a question from earlier we never got to either, if Malcolm's here.
Malcolm's not here yet.
Yeah, thanks, everybody. Yeah, I'm wondering about the cameras are on. There we go. Wondering when this is called complete, I guess the coverage showing here 100% in the offshore environment, 56%. What resolution is that brought to? Is there sort of standard for that? Or is that across the whole domain of 20 to 200, or does it vary based on depth ranges?
So I might lob that to the vendors. They may have more detailed discussion with FDEP, but FCMaP, we made a recommendation that I think this was the original report that it was when I was with USGS, was that in the 0 to 10 meter water depth, the data be collected to support a 1 meter DEM. In the 0 to 20 meter water depth, or the 10 to 20 meter water depth, 1 meter is ideal, but 3 meters would be acceptable. And in waters deeper than 20 meters, I think we were talking about, 3 meters is ideal, but 10 meters would be acceptable, was the standard that we had suggested as FCMaP. I know that I think to some degree that the FSMI was adhering to some of that. I know all vendors are focused on shallow water, the shallow water data collects right now, but have you had any discussion about the deeper water data collects and the resolution of the data that they're going to be required by the state for those? Looking at Rick, Amar or Emily.
I don't remember the RFP offhand for the deeper waters in terms of what was the requirement, but it's listed out there in terms of what the DEM requirement is. And I will add that there's a QMP document that's forthcoming that will really detail in terms of based on depth ranges, what the resolution and what the, holidays, voids, et cetera, are going to be.
Does that answer your question, Chris?
Sorry, yeah, Cheryl, thanks. That's much finer resolution than I thought. Previous gap analyses have used like a sounding within 100 square meters, that sort of thing. So yeah, it's good to know that you're basing it on sort of technological limits than sort of an overall gross resolution for coverage. Thanks.
Yeah, absolutely. Yep. Lots of questions. I think we really, going back to the conversation we had just before this, I think that some of the numbers, especially there's two pieces of communication here. One is even though we've made progress, there's large areas, especially in that 0 to 20 meter, 200 meter water depth, the 20 to 200 meter water depth that are very important, that are a very high priority for a lot of stakeholders. And, while we've made some progress, there's still a lot to be done. I think the other thing, the messaging is that although we have significant success in the near shore zone, which is the 0 to 200, that's the zone that will change the most with all the storms and the different drivers of coastal change. And so those are, even though the data have been collected, it's imperative to collect those on some sort of regular temporal scale. So that would just be my recommended messaging as we push this forward, and I'm happy to entertain other people's recommendations. Cheryl's subtle push for let's have a conversation. Okay. All right. Well, we're done early.
Yeah,
for
hungry
lunch.
people ready for lunch.
Hungry people ready for lunch. Yeah. Okay.
Great. Thanks, Cheryl. All right, so we're going to break a little bit early for lunch. Lunch is provided outside. There's brown bags. Thanks again to our sponsors for making it possible that we have on-site lunch provided. We are scheduled to get back on for those online. We will try to start on time. It looks like 12:50 is our first presentation. So yeah, we're going to get back online here. Let's make our way back in by 12:50, please. Thanks.
Yeah, and you're welcome to grab a lunch and wander outside and find there's walls to sit on. I don't know if there's picnic tables anywhere. I think there are. Yeah, sit downstairs. Don't feel like you have to stay in this cold room.